Okay, so we're going to do a quick wrap up because you've talked a lot about rectilinear motion, but we haven't really nailed it all together and made it all coalesce into one type of whole. So that's what my goal is in this video. So the first thing we're going to have to do here is we're going to talk about things you need to know for each type of equation. So one of the equations you need to understand is a position equation. So position kind of has different meanings depending on what's going on. So your position is really a displacement from an origin point. So that might be your horizontal or your vertical position, that might be left, right, it might be close, far, things like that. So your position is really a displacement from an origin point. And usually we're going to have position as x of t or sometimes s of t for position. Every once in a while, you might have p of t, and if it's a vertical, we'll often call it h of t. Our displacement is really going to be our positive or negative distance from an origin point over a given interval often. So our displacement is really x of t2 minus x of t1. So your displacement is your position from one point to another point. What's the difference between them? Average velocity, and this is what a lot of people make mistakes on, average velocity is displacement divided by time. Okay, elapsed. So average velocity does not have velocity in it. There is no v in the average velocity formula. So our average velocity is x of t2 minus x of t1 divided by t2 minus t1, or delta x over delta t. There is no v in that expression. Instantaneous velocity, on the other hand, is your derivative. That's your velocity at one specific time. So my instantaneous velocity is the derivative of position at some value of t, like t equals c or something like that. So you can call that x prime of t, you can call that h prime of t, you can also call that v of t, and we deal with it as long as I know where your v came from. You can't just make v come out of nowhere. You have to set it equal to h prime so I know what derivative you took. Speed is always the absolute value of velocity. Always, always, always. So it's the absolute value of v of t, which means it's positive or zero, but never negative. Speed cannot be negative. So your speed is the absolute value of v of t. Acceleration, on the other hand, is the derivative of velocity. And that's going to be h double prime of t, or x double prime of t, or a of t, or v prime of t. Anything like that is fine, but if you're going to call it a of t, you have to set a of t equal to something else. I know my camera's probably going crazy right now. I'm trying to figure out this webcam thing as I write. So there's acceleration. Okay. Now let's go to example 1, and I'm just going to try and plow through this example quickly to get you all the specific points you need to as quickly as I can. So in this case, it says the height of an object can be modeled by this equation. Fantastic. In what direction is the object moving? And you know what? To make this go even faster, before we do this, why don't you turn the page? And we're going to turn the page and put in these signs right here so that I can reference them. So let's do signs and their meanings. So when an object is to the right or above the origin, position is positive. So right or up, positive. When you're left or below, left or down, is going to be negative for position. That makes sense. When an object is moving to the right or moving up, velocity is positive. So again, right and up means positive. Down or to the left means negative when it comes to velocity as well. Now, you're not going to be doing both. We're either going to talk about horizontal motion or vertical motion, either or, not both. All right. Now, here's where things get a little bit trickier, so make sure you're following along. When velocity increases, that means v of t is increasing. The slope of v is positive, therefore, the derivative of v is positive, which means acceleration is positive. Acceleration is the derivative of velocity. Acceleration and accelerate, not the same thing. So try to ignore the word accelerate, ignore the word decelerate, don't say them ever again. We're only going to deal with positive acceleration or negative acceleration. Deal? Deal. So if velocity is increasing, acceleration is positive. If velocity is decreasing, acceleration is negative. That makes sense because it has to do with the derivative. When something increases, its derivative is positive. Now, more thinking. When the graph of velocity moves away from the x-axis, that means that your velocity value is getting further from zero, which means the absolute value of that number is increasing. So your speed is increasing. Okay, so when velocity moves away from the x-axis, speed increases. Conversely, if velocity moves toward the x-axis, speed is decreasing. Okay, now, when velocity and acceleration have the same sign, that might mean that I have positive velocity, I'm moving upward, and my velocity is increasing, so I'm moving upward and increasing, which means that my speed is increasing. When velocity and acceleration have the same sign, that's when you're speeding up. And the easiest way for me to describe that is acceleration is you being pulled. Velocity is you moving on your own. So if you're moving in a certain direction and being pulled in that same direction, you're going to speed up. On the other hand, if your velocity and acceleration have different signs, that means you're moving in one direction but being pulled in the other direction. So your speed is decreasing. Okay? These come up a lot, as does everything else, but those two on the bottom aren't really intuitive until you really think about it. So make sure that makes sense. So now let's go back. So I have the height of an object can be modeled by this equation here. Fantastic. In what direction is the object moving when t equals 1 or when t equals 2? If I am moving, I want to look at my velocity. So what I'm going to do here is I'm going to take s of t and say s prime of t, which is v of t, is my derivative, and that's going to be 11 minus 32t. S prime of 1 is 11 minus 32, which is going to be negative 21. S prime of 2 is 11 minus 32 times 2, which is like super duper negative. So that's negative 64. So what do I have? Negative 53 for the difference there. So since S prime of 1 and S prime of 2 are negative, the object is moving. Now, this is height. Height is an up-down direction, and so since I have a negative up-down direction, that means I am moving downward. Okay? All right, so there's that one. Next, what is the speed of the object at the moment when its height is 0? Okay, well, if I want my height to be 0, I'm going to say 5 plus 11t minus 16t squared equals 0. I'm going to set my height equal to 0. I'm going to use the calculator to figure that out because it's good practice. I don't even know if this is factorable. I honestly don't even care right now because I just want to do it. Come on, computer. There we go. So in the calculator, I have 5 plus 11t minus 16t squared. So 5 plus 11x minus 16x squared. I want to know when it equals 0, so I'm going to set my x min and max to 0 to 10, and my y min and max to negative 1 to 1, because all I care about is where it crosses. Look at that, it's pretty early on. Second, calc 0. that looks like it hits at about 1. So left bound is 0, right bound is 2. I'm going to guess at about 1. Look at that. My 0 is at exactly x equals 1. So that's going to happen at t equals 1. So the height is 0 at t equals 1. But Mrs. Weber, what about negative 1? I'm going to say, since we know that this is the height of the object, I'm going to ignore the t's being negative. If this wasn't notes, if this were a quiz or something, I would have written down t is greater than or equal to 0 to tell you to ignore all the negative t's. So let's just pretend I did that and move on with our lives. So my height equals 0 at t equals 1. I want to know the speed there. And look at that. I almost kind of already did the speed. I got a velocity of negative 21, which means, whoops, sorry about that, which means my speed at t equals 1 is positive 21. Ta-da! Is the object speeding up or slowing down when t equals 1? All right, so speeding up or slowing down. There are two ways to do this. Option 1 is look at the graph of velocity. Option 2 is look at the sign of v and a. All right, so I'm going to look at the graph of velocity, which would be my derivative graph. So over here, my position graph is that. I'm going to turn that off, and I'm going to graph the derivative, which is going to be 11 minus 32t, which is 32x. And I'm going to zoom 6 this because I want to see the whole graph. All right, and then what was the question again? Is it speeding up or slowing down when t equals 1? Well, at t equals 1, let's see, that's right here. My velocity graph is below the x-axis and moving away from the x-axis. So we would say, using the graph of v of t is moving away from the x-axis, so speed is increasing. Okay, because my velocity is negative and getting more negative, so my speed is increasing. The other way to look at it would be to look at s prime of 1 and s double prime of 1. So s prime of 1 we already got is negative 21. And since, let's see, s prime is 11 minus 32t, s double prime is negative 32. They have the same sign, so I am moving in the same direction at which I'm being pulled. So since s prime of 1 and s double prime of 1 have the same sign, it is speeding up. Okay? What is the average velocity of the object on the interval from 1 to 2? So average velocity has actually nothing to do with velocity. It's displacement over time. So my average velocity is going to be x of 2, which actually in ours is s. So let me change that. My apologies. It's going to be s of 2 minus s of 1 over 2 minus 1. That's average velocity displacement over time. So s of 2 is going to be 5 plus 22 minus 64 minus s of 1, 5 plus 11 minus 16, all over 1. And I don't know, that's something mathy. Let's see, my 5s would be gone. 22 minus 11 is 11. Negative 64 plus 16 is what? Negative 48. Which is going to be negative, what, 37, I think. So the average velocity is negative 37. All right, I am going to stop there because I don't want this video to be exceedingly long, and I want to make sure we can talk about the rest of it tomorrow in class. So we're going to leave example 2 and the example after that for class. You do not need to do them on your own. Bad joke of the day is, why did the Scarecrow get an award? Because he was outstanding in his field. Outstanding in his field, ladies and gentlemen. That is the bad joke of the day. Enjoy the rest of your day, and I will see all of you later if I can figure out how to stop this video. There it is. No, it disappeared. There we go. Bye.